Hello everyone, and welcome to about Academy. In today's video, we are going to be looking at this question, and this question is coming from electricity and circuit. So you have to be able to understand how you can be able to calculate the current, the resistance, as well as the voltage. Now remember that one of the most fundamental principles when it comes to electricity is the understanding of what is called Ohm's law. And in every circuit that you come across, the only fundamental principle, whether one of the most commonly used formula in electricity, is Ohm's law. And this is the circuit diagram, and that's what we're going to do and be able to use that formula in order to calculate whatever the question is asking us to calculate. So this is about, we have the circuit and we have the voltage as 24 volts. And then we have the resistors that are in parallel, as well as one that is in series. Now, the first question is saying now, what is the combined resistance of the 6 ohm resistor and the 12 ohms resistors in parallel? So they are asking us to find the combination of these two resistors. What is the combined resistance of these two? Okay. So now, the formula, when you have these resistors, what you're supposed to do is, we just say 1 over RC equals to 1 over R1 plus 1 over R2. Now, this formula says that if you have two resistors, then we can actually take the reciprocal of each resistor, meaning 1 over the resistor, 1 over, that is 1 over R1 or 1 over R2. So this one could be R1, this one could be R2. Now, whichever you're putting the R1 or the R2, it is up to you, but at the end of the day, we should be able to get the same answer. Okay, so now from there, we can now see is 1 over this 6 plus 1 over 12. Okay, now as simple as that. Now we can go back to the fraction and find the lowest common denominator between 6 and 12. And this is going to be just 12. Okay, and now this into that is 2 times 1, that is 2 plus 12 into 12, that is 1 times 1, that is this one. So you have now 3 out of 12, and then this one is 1 over RC. Now, I've just actually designated RC to be combined resistor. Okay, so don't get confused about what the RC is actually meaning. Okay, so the most fundamental principle is that we can designate if something is not actually properly done. So RC is this combined resistance. Okay, so once you have this, now you can actually cross multiply. So this is going to be 3 RC equals 12. And now what you have, so now what you have is, you divide now, okay, this over 3, this over 3. So now this means that you get the combined resistance between the 12 ohm resistor and the 6 ohm resistor. You get now 4 ohms resistor, or rather 4 ohms. Okay, so meaning that is a combination of the 6 and the 12 ohm resistance. Okay, so that is the answer on question 1. So the question 2, which is B, what is the current in the 8 ohm resistor, or this one? What is the current? Okay, now you have to understand a bit. When you're talking about current that is passing in the series resistor connection, what you're supposed to understand is that this the current passing in the series is actually just calculated using the total resistance of the circuit as well as the total voltage that is coming from the battery. Okay, so what are you supposed to do? Just use Ohm's law. Okay, so again we are going to say total Now, what is the total resistance? Now, the total resistance is the combination of this and also the combined resistance of the 12 and the 6 ohm resistor. So this is going to be R, this equals to, this one was found to be 4 plus this one, okay? And then we should be able to get, so our total resistance of this entire circuit is now 12 ohm resistor. Okay. Now we have to find the total current that is flowing in this circuit. So the Ohm's law, or rather the formula for finding resistance, is called Ohm's law, or rather this mathematically, R equals to V over I. So R is resistance and V is actually voltage and I is current. Now we know that you are looking for I, so then we can make I the subject of the formula. So now this is going to be this V equals to I R. So you cross multiply and then 1 times V is V and then I times R equals to I R. And then now we are looking for I. We divide both sides of the equation by R. So now we are going to have as I equals to V over R. Now we know that the R that you're going to use is the total resistance of the circuit and the voltage is the total voltage of the circuit. So now this is going to be, so total voltage is at 24 and the total resistance is just found to be 12. So this is going to be, now the moment you find out the total current that is flowing this circuit, that is the same current that is passing through this resistor, which is the 8 ohm resistor. So this is the current that is flowing. Okay. So from this part we have 2. Okay. Now the most fundamental principle that I want you to understand is this. So when the current is flowing and it reaches at this point, now this point is actually sort of like the junction. So the other part is actually going to the 6 ohm resistor and the other part of the current is going to the 12 ohm resistor. Okay, so this is the principle that we must understand. Okay, so there is a current divider. At this point, current is now being divided. However, when the current actually gets to this point, okay, so whatever the amount of current is actually flowing to this point, and that which is flowing to this point, they come again, rejoin at this junction. So which means that whatever the current, this was 2 ohms, and then it is going to reappear at this point, or it is going to actually, sum up from the 6 and the 12. They are going to sum up, and this is actually going to receive the 2 amps as the current at 8 ohm resistor. So it's kind of very straightforward that you have to see how much of the current is actually flowing at that point. Okay, so from that point, we can now conclude that the current now, the current flowing at this one is actually just the, so 2 amps is the amount of current that is flowing at that point on the 8 ohm resistor. So let's go to the third question. What is the voltage across the parallel network? So what is the voltage that is passing through the 6 ohm resistor and the 12 ohm resistor? So we are being told to find the voltage. Now, here's the concept about Kirchoff's law. Now, Kirchoff's law states that the voltage in the parallel network or connection actually is the same, okay? While the voltage passing through at the resistor that is in series, then it simply means that that voltage is different from that one which is passing in the parallel connection. Therefore, if I find the voltage in the series connection, then I'll just subtract from the total voltage, then the remaining voltage is going to be the voltage that is being shared on the parallel network of those resistors. So now let us see how that works out. So now in order now to find the voltage across the 8 ohm resistor, what is just supposed to do is find the voltage, across the parallel, just find the voltage at the 8 ohm resistor and then subtract that same answer from the bigger, the total voltage. So what is going to happen is this. So at this point, you're going to say R equals to V over I. Now, this is Ohm's law, okay, or rather by the scientist George Simon Ohm. Now, this formula, how is it going to work? We need to find the voltage. So we make V the substitute formula. So V3, what am I talking about? So this is the voltage at the third resistor. So the 3 is just a numerical representation that I'm referring to the voltage on the third, or rather number 3 of these resistors. So this is going to be I, meaning the total multiplied by the current at that point. The resistor at that point. So what this means is that I'm going to take the total, the total voltage multiplied by the resistor at resistor of, which is this one, meaning R3, because this one is R1, this one is actually R2, and this one could be just R3. So what is going to happen? Now we know that total current, the total current flowing this one is 8 amps, and then the resistor is just 8. Okay, so now what you do is you say it's 2 multiplied by 8. So this is going to be 16. So we are now finding the specific voltage, though the question says the voltage across the combined or the network of the parallel network of those resistors in the parallel connection. So why are we doing that? It is very simple. Because voltage in series and voltage in the parallel resistors are not the same. Okay? Are not the same. So if I find the voltage in the series, then I'll just get the total voltage and subtract with that of the voltage from the series. And this will give me the remaining voltage that is being shared across the network of parallel, or rather the parallel network of resistors. So therefore, voltage at these 2 points is just going to be voltage, okay, across the 6 ohm and the 12 ohm is going to be the total voltage minus voltage at 3. Okay. So voltage, okay, total voltage, that is 24, minus the voltage at 8 ohm resistor. And this is going to be, that is 16. So now 24 minus 16, this will give me now 8. Okay. So now I have now the energy that is being actually delivered to the 6 ohm resistor as well as the 12 ohm resistor, which is just 8 volts. And the energy that is being delivered to this 8 ohm resistor is simply 16 volts. Okay. Now, what is the last question? Now, the last question is actually asking about the current that is passing through the 6 ohm resistor. Now, remember, according to Kirchoff's law, okay, in parallel, the current that is flowing in that actually, those resistors that are in parallel is actually different with the current that is flowing from the resistor that is in series. So what is going to happen now is that I'm just going to find, the current that is flowing there, even if I know the current that is flowing in the entire circuit, which is 2 amps. Okay. Okay, so now what is going to happen is I'm looking for the current in the 6 ohm resistor. I'm looking for the current at the 6 ohm resistor. Now, this is in parallel, okay? The current in the parallel is actually not the same as that one and in the series connection, or rather series resistors that are in series. So what is going to happen now is, I'll just say, now, what am I looking at? I know that the voltage across this, the parallel network of this resistor is, the voltage is actually was 8 volts, and I know that I'm looking for the current, okay, and what is the resistor is actually the 6 ohm resistor, and this is a 6. So that is the information that I'm supposed to use in the equation. So I'm looking for the current, therefore I'm going to make I the subject of the formula, the subject formula, yeah, from this general formula. So this is going to be I equals to, V over R. Okay. So I equals to V over R. This is now going to be, the voltage is actually 8, okay, and then the resistor is actually 6. Okay. Now, of course, I'm not using the calculator, so you guys can confirm. So I can say 2 there, it's 3, 2 there, it's 4. So this is the same as saying 4 over 3, which is 1.3, 1.3. Of course, I've actually rounded off the answer to 1.3. Of course, the number would just go 1.333. But the most important thing to understand is this. You have been able to find the current at the 6 ohm resistor. Now, what does that mean is this. So, on this part, okay, we have 1.3 as the current. Now, what do you think could be the current that is flowing to the other side of the resistor, which is a 12 ohm resistor? So, this part, the 12 ohm resistor. You know that we have the total current that is 2 amps. And we know that just from there, that the current that is flowing on the 6 ohm resistor is 1.3. So remember, the Kirchoff's junction rule is that when the current actually comes at this point, it is actually distributed, okay, based on the resistors that we have. So we have the 6, the 8, 12 resistor. So now we know at this point we have 1.3 amps. And at this point, we don't know. But again, when the current actually reaches at this point, it has actually to recombine, okay, before it actually gets back to the battery. Okay. So now, we know that the total current is actually, that is 2. So then to find the current that is passing through on the 12 ohm resistor, I'll just actually say that 2 minus 1.3, okay? 2 minus 1.3, because the 2 is the total current that is flowing in the entire circuit. And I also know that at the 6, on the 6 ohm resistor, I know that it is 1.3. So obviously, this will give me, so 0.7 amps is actually flowing to the 12 ohm resistor. So you have to think about this, okay? When the current actually goes in different ways, and then they have to meet at another junction. They are leaving out now. They have to meet, so they have to actually to recombine. So the 1.3 plus the 0.7, then we get back to the total current, which is 12 amps, and that's how you can go about answering this question. Remember, it is very easy and straightforward once you understand the basic principle of circuit analysis and understanding what is resistance, what is current, what is also a voltage. When you understand these three terms, that forms what we call the Ohm's law, which is resistance is equal to the voltage divided by the current. And this number actually is constant, okay? It is constant because despite the voltage changing, the current changing, but we keep on actually getting the same answer. And that is what we call this. The constant value is normally referred to as the resistance of that particular conductor or that particular appliance or whatever electronic device that you are referring to. Otherwise, thank you so much for watching. Remember to support me. You can actually check me out on Facebook, YouTube, as well as TikTok. Just search for Radko Karim, or you can also go specifically to my profile account on Facebook, search for Mike Warrior, and be able to see all these videos and other different videos. So remember to stay updated by liking, subscribing, as well as following me on all those social media accounts. Thank you so much, and I'll see you in the next video. It's bye-bye, and God bless.